So here's the model of an eye. As you guys see, the eyeball actually has 6 muscles attached to the outside of the eyes. That's why some of you can roll your eyes so hard. And that's why some of you maybe have not been able to roll your eyes successfully. Just practice, because the more often you use those eye muscles, the stronger they will get, okay? We'll talk about the different muscles, what do they do, and what happens if there's something wrong with them later. But each eyeball has 6 muscles. That's 12 muscles just for your eyes. That's crazy. And some have said that the eye seems equivalent to like the Russian doll because there's like different layers to the eye. Okay. Lots of layers. Lots of layers. This is very similar, although this piece is a little maybe not that accurate. There are parts to the eye, and they all kind of just form a little Russian doll, layer after layer. Just like all the parts of your body, just layers, right? Skin, layers, muscles, layers, bones, layers, eyeballs, layers. But the view that we have on the paper is a lateral view, so you're actually looking at it from the side here, and we have sliced it this way so that you can see on the inside of the eyeball. But look at all these parts, guys. There's a lot of parts. They all have their own job. You just want to simplify this in your head. An eyeball is just like a water balloon. 2 water balloons. Okay? All right. So we're going to go ahead and use your blue. You're going to color in very lightly because we're going to use your blue twice. So we're going to use it very lightly. The very front of your eyes, actually go ahead and take a second to appreciate this. Go ahead and stare at your partner's eyes. Just notice all the parts of their eyes. Look at the side view, front view. That's fine, look at it from the side. You want to look at it from the side too. You don't have to look at him. He wants to see the side of your eyes. That's it. Okay. All right. So notice where I start and stop coloring. So notice I only color a certain portion of that outermost layer. When you're looking at somebody's eyes, what do you guys notice? Their color, the iris of the eye, the color. So what that means is that there's a part of your eye that has a color to it. However, that's not the most front, that's not the most anterior part of your eye. There is a layer in front of that colored part of your eye called the clear layer here. This is number 1. This is going to be our cornea. You guys heard of cornea before? Like people scratch their cornea, yep. So number 1, cornea. So even though you can see the color of somebody's eyes, there's actually a clear layer in front of that color, but you can't see it because it's clear. So we're going to write transparent. Ooh, I forgot to add something. Hang on. Transparent. What does the word transparent mean? It's transparent. It means it's see-through. You can't really see it. If you look at somebody's eyes from the side, you may be able to see that there is that clear outer layer. It almost looks like a bump, like contact lenses, but it's a part of your eye. Yeah. It has no blood vessels. If it did, that'd be weird because you'd be able to see them because it's in the front of your eye. There are many nerves. And the shape is very particular. It is convex. What does convex mean? There you go. It goes outward. So it bulges out. So that means your eyes aren't perfect spheres. The front of them do have a bulge to it. And the convex shape of the cornea is very important. It actually helps refract light. So in order for you to see, you have to have light. That's why it's hard to see at nighttime. There's no light. But the light has to be sent into your eye, has to be focused in your eye, and the only way that light can get focused properly is if the cornea is the correct shape. Some of you, maybe your corneas are slightly different shape, and that's okay, and that's what you call like astigmatism. Yeah. Yeah, that's why your contact lenses cost more. It's because your cornea shape is different. Okay. Here's what I forgot to add. The outermost layer, the cornea included, is called the outer tunic. So if you have space, you're just going to squeeze outer tunic, sometimes called the fibrous layer. What do you guys think of when you hear the word fibrous? Fiber, muscle, so tough, strong. The outermost layer of your eye has to be fibrous. It has to be tough. It has to be strong. It has to be like armor, okay? Your eyes go through a lot. You're biking, bug flies in your eye. You're rubbing your eye, eyelash in your eye. Trying to grab your contacts, scratch your eye. Putting on makeup, mascara wand in the eye, right? Like, your eyes go through a lot. You have to have a tough outer layer or else it's not gonna go well. This part of the eye, the outer tunic here that we didn't color in, these are the whites of your eye. So that's going to be our number 2. So the whites of your eyes are called the sclera. So can you please say sclera? Sclera is the white, opaque covering of the eye. It is also quite tough. Do you guys know what opaque means?
Yeah. Not transparent.
Not see-through. Not as see-through. Okay. Opaqueness can have different densities. So you can have some that are super opaque and some not so opaque. Kind of like you guys know tights or leggings. Some are like super opaque and some are not opaque enough. Yeah, the struggles. The middle layer of the eyes are called the vascular layer or the middle tunic. Vascular, as in cardiovascular. So what does vascular mean? Any guesses? Blood. There you go. This layer has blood vessels. The outer tunic does not. So in the picture, they kind of try to show you they're peeling the inside layer downward right here so that you can see that there are layers to the eye. So what I'm going to do is I'm going to use my red color. Notice I'm going to start coloring right here and I'm going to end coloring right here. So everything in between that. So using my reddish color here. This is called the choroid coat. Can you please say choroid coat? So this layer of the eye, right beneath the sclera, has blood vessels. You can kind of see in the printout, it has the blood vessels drawn in. Since it has blood vessels, that means it has nutrients and oxygen. And so it will provide nutrients and oxygen for the outer layer of the eye. It's kind of like the dermis providing oxygen and nutrients for the epidermis. So if you've ever seen somebody who got somehow hit in the eye or something hit their eye or something or accidentally poked in the eye and you see their eye like bleeding, that means that they had a puncture all the way through to the choroid coat.
I have a question.
Yes.
What if people just bleed from their eye?
Then that's like if it's coming down like as a tear,
Yeah.
then that means there's something on the outside because there's a vascularization in the tissue surrounding the eye. But if the choroid coat bleeds, the blood can't get out because there's the outer sclera and cornea layer covering it.
What if they get like stitches?
If they get stitches, then on the outside of their eye?
What?
On the outside of their eye?
Yeah.
Then it won't bleed because it's on the outside of their eye. There's no blood vessels. Yeah. If you scratch your cornea.
Is that how you like when you pop a blood vessel in your eye?
That's why it stays in there. It won't like come out. It won't like tear out, right?
Okay.
Yeah.
So it's caused by like extreme pressure or something like that?
Or yeah, like a
Like getting hit?
hit or some blunt force to the eye. Like pop a blood vessel, like if you had hypertension, like really high blood pressure, I guess, maybe. All right, so that is the choroid coat. We're gonna label that number 3. Choroid coat. So this is the thin vascular layer. It's vascular, which means it has blood, and so it supplies oxygen and nutrients to those layers that don't have any blood vessels. And then I'm going to use red again to color a part of the choroid coat that we haven't colored yet. So notice in the picture, we kind of left out these little blobs at the end of the choroid coat. I don't know how to explain that shape. It kind of looks like an amoeba looking deal. That end right there is actually muscle. So the choroid coat ends in muscles here. So what we're going to do is we're going to outline and color in. Here is one of the muscles that changes the shapes of your lens. And the muscle is circular, so it encircles your whole lens. So inside of your eye, you have this clear disc called the lens. The lens can change shape, but only if those muscles contract and relax. If those muscles won't contract, relax, then the lens can't change shapes. Okay. Notice that the muscles are holding on to that lens with these little spider web things. Those are called suspensory ligaments. So if you are looking at somebody's eyes from a front anterior view, so anterior view, that muscle would be right behind the colored part of your eye. So if we take out the colored part of your eye, this would be the lens, the centerpiece right here. And then there would be this muscle circles it that would change the shape of this middle lens here. Okay. So it is a circular muscle, and we're going to label that number 4. The ciliary body. Can you please say ciliary body? Ciliary body. So it's a round muscle. It is made up of smooth muscle. Does anybody remember, is smooth muscle voluntary or involuntary? Involuntary. Good, involuntary. That means you don't really choose when it contracts or relaxes. It kind of just does its own thing. Its job is to change the shape of the lens to help you focus on an image. So it's almost like the lens on a microscope. You can focus the lens so that you can see clearly, and if it's not focused, the image will be slightly blurry.
So is that like when you turn off the lights and then our pupils get smaller and then when we turn them on our pupils get larger?
So that is actually going to have to do with the iris itself. This would be an example. We can do this example right now, actually. Go ahead and put your hand maybe like 3 inches in front of your face. And I want you to look at your hand, your palm, very carefully, okay? Is it clear? Make sure it's very clear to you. Do you guys see those lines on your palm? Maybe you see how ashy your palm is. Maybe you see some ketchup that's left over from lunch, okay? So is your hand very clear? Okay, when I count to 3, I want you to look up at the TV, okay? So stare at your hand. 1, 2, 3. So you see how it was blurry and then I got clear real quick? Try it again if it didn't work for you. It's like exactly like autofocus. Yep. Or maybe look farther if the TV is too close for you.
Wait, so is it like, you know like those things
Maybe like all the way out the window or something. If it's yeah, so you focus on an image, right? When you look at something farther away, the lens has to change shape for that image to come into focus. And so the ciliary bodies are either going to have to contract and pull the lens flatter or relax so the lens can like get wider and that way you can see farther away. But for some of you, your ciliary bodies don't work well, or your lens won't cooperate. So that's when you have like near